Okay, so now we're going to deal with a perfect square trinomial. Now, that AC method we were doing, it's going to work on all of these. Okay, not a problem. But I'm going to show you this other method. So if you have a trinomial such that the first term can be written as something squared and the last term can be written as something squared, and then if those two things that are being squared, u and 4, if you can put them in the middle and multiply them by 2 and end up with this middle term, which we do in this case, then you have what's called a perfect square trinomial. Okay. So how's that going to factor? Well, it's going to factor like this. The thing being squared goes, the first thing being squared goes there, the second thing being squared goes there. And then it's looks like that. So, and then this would be your final answer. But that, of course, is the same thing as u plus 4 times u plus 4. So if you ran this thing to the AC method or that shortcut we saw once upon a time, you're going to get the same thing. Okay. So that's, let me do one more of those. All right, so on this one, yeah, the first term, the first term is something squared, v squared. The last term is something squared, 1 squared. So if I go v times 1 and then times 2, do I get the middle term? Not quite. The middle term is negative 2v, and I've got positive 2v. So when that happens, when you're just off by a sign and that's it, all you got to do is just say, all right, well, then this last guy is negative. Well, I know it seems kind of like I'm just making stuff up, but, well, negative 1 squared, that is 1. And if this is negative 1, the thing being squared, then that's negative 1 right there. Okay. And therefore, I now have negative 2v there in the middle. So I can rewrite this as v and negative 1, and the whole thing squared. So that's what happens when you've got that minus sign right there. You just end up with a minus sign right there. But you know, this is why. Okay, now on this one, same thing, except now a, the leading coefficient, is not 1. All right, but I can still write that leading term as something squared, and the last term, 81, as something squared. Okay, cool. But I've got that minus there, so I better just make it a negative 9 right off the bat. Okay. Now, in the middle, I'll write the 2y. I'll write the negative 9. And then I will introduce an extra factor of 2. And is that equal to the middle term? Yeah, they're both negative 36y. Therefore, I can write this as the first thing being squared plus the second thing being squared, or just minus 9. And that'll do it. And now we do another one of those, but now there's an extra variable. Who cares? Now, again, bear in mind, these stuff we've already seen in the past will cover all of this, that AC method stuff. It'll cover all of this. But, you know, if you get good at this, it's a nice shortcut when it pops up. All right, so on this one, I could ignore the w's, that second variable, if I want to, and then slap them in at the end. Since that's the way we've done it, that's the way I'm going to do it. I don't have to, but I'm going to do that. All right, so temporarily, I'm going to ignore those w's, okay? So then I say, hey, that first term, yeah, that's a perfect square. I can write that as 3v quantity squared. And that last term, yeah, that's a perfect square, but I've got that minus there. So again, I'll make it a minus 5. Okay, so in the middle, I've got, let's see, I've got the 3v, I got the negative 5, and let's see. And then if I throw in a 2, does that match up with this guy, with negative 30v? Sure does. Okay, so I can rewrite this as with a 3v, with a minus 5, and then don't don't forget the W at the end that we were temporarily ignoring, and that's how it's done. All right, so now we're clearly not doing differences or perfect square trinomial because there's only two terms. So when there are only two terms, you can still do the AC method from before. But a lot of people do prefer the alternative method, and that is, hey, if these two terms have a subtraction sign between them, which obviously they do, and you can write both of them as something squared, they're both perfect squares, then you can just factor like this and just take those things that are being squared and make one minus and one plus. Doesn't matter which, just make sure they're opposite. If you multiply this all out, you'll get this. Or if you plug that in for y1, that in for y2 in your calculator, go to the table, you'll see that they match. That's how it's done. Okay, so here's a different one. Well, I know the square root of 81 is 9, and the square root of x squared is x. And the square root of 64 is 8. And there is a subtraction between them, so I can do this difference of squares factoring technique. That's the name of it. And just go, like minus plus or plus minus. It doesn't matter. It doesn't make a difference. That's it. Now I'll do difference of squares where there's two variables. Well, the square root of 6, it's just two terms. It's subtraction in the middle, and I know the square root of both. Therefore, this is a difference of squares situation. So the square root of 16 is 4. Square root of v squared is v. Square root of w squared is w. And I'm done. That's it. Not a lot to do. Now on this one, once again, it's just two terms. So we're thinking difference of squares. It's a little different though. One thing you could do is go straight to difference of squares. You could. And just say, well, it's 3w squared minus 9w and 3w squared plus 9w. You could do that. And then you could say, whoa, wait a minute. I can pull a 3w out of that, a 3w out of that, and get this. And then I could, get these three w's together, and then I could say, all right, 9w squared, w minus 3, w plus 3. And then y1, y2, you see that they match. Okay, that's one way of doing it. That's not the way the author's hoping we'll do it, but yeah, whatever. Okay, so here is an alternative method. It's just to say, hey, is there a greatest common factor? Because typically that's the better way to go, because you tend to avoid more challenging issues. Is there a greatest common factor? Yeah, I can pull a 9 out and a couple of w's. So I'm left with that. That looks familiar. And now I've got a difference of squares right there. Using w and 3. And I get to the same answer. Okay. So I typically will say, yeah, pull the GCF out first. Sometimes it's not necessary, but I just think it makes it easier.